Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 4-4 Part 2 homework solutions. In this one, we're dealing with factoring polynomials that are a difference or a sum of cubes, and also the factor theorem, and factoring polynomials using synthetic division. On this problem, as always, let me check for common factors. It doesn't look like there are any that I can take out. So the next thing I'm noticing here is that I have an x cubed, and 64 is also a perfect cube. So I can actually use my perfect cube shortcut, the sum of two cubes, which, let me write that out. That's going to be a plus b times a squared minus ab plus b squared. That's what I have to split this up into. So to do this, I'm just going to take the cube root of x cubed and 64. Cube root of x cubed is just x, that's my a value. Cube root of 64 is 4, that's my b value. So I have an x plus 4 for that first parentheses. And then a squared is going to be x squared. Minus ab is going to be minus x times 4, so minus 4x. And then b squared is 4 squared, so that's going to be 16, and that's as factored as these things are ever going to get. For this problem, I notice I have a difference of two perfect cubes. 27 is 3 cubed. So I can use my perfect cube shortcut for a cubed minus b cubed. That's going to be a minus b, a squared plus 2a, or plus ab, and then plus b squared. So to get my a value, I have to take the cube root of c cubed, which is just c. For the b value, I need the cube root of 27, which again is 3, so minus 3 here. A cubed then is just going to be c cubed, plus ab is going to be plus c times 3, so plus 3c. And then b cubed is 3 cubed, so that's plus 9. On this problem, just like I always do, I'm going to see if I can take out a common factor. Now, we've got a 16 and a 250. I know that I can at least take out a 2 from these, but I'm kind of wondering if I can do better, like maybe a 4 or an 8 or a 16. Let's see if I can take out a 4 from those. So I know 16 is divisible by 4, but how about 250? 250 divided by 4, nope, can't take out a 4. That doesn't come out evenly. And if I can't take out a 4, then I certainly can't take out an 8. And if I can't take out an 8, I can't take out a 16. So it looks like 2 is as good as we're going to do for common factors. Now for variables, the lowest exponent is this t to the 4th term here. So I can take out a 2 and a t to the 4th. And that'll just have to be good enough. Let's see what happens when we do that. So 16t to the 7th divided by 2t to the 4th, that's going to be 8t to the 7 minus 4, so t cubed. And then 250 divided by 2 is 125, and those 4th power t's are canceling completely, so we have a plus 125. Now here is the good news. 8t cubed is a perfect cube, so is 125. So I can use one of those perfect cube shortcuts, the a cubed plus b cubed one. And remember that shortcut gives us a plus b and a squared minus ab plus b squared. So I've got the 2t to the 4th that I took out initially, don't want to lose that. And now to get these a's and b's, I need to take the cube roots of 8t cubed and 125. Cube root of 8t cubed is going to be 2t, so that's my a value. My b value is the cube root of 125, which is 5, so we have a plus 5 there. And now a squared is going to be 2t squared, so 4t squared. And then minus ab is going to be negative 2t times 5, so negative 10t. And then b squared is 5 squared, so a plus 25 there. And that's as good as it gets. For this problem, to figure out if x plus 4 is a factor of this h of x polynomial, we're going to use a little synthetic division and see if we end up with a 0 for a remainder. So writing out my coefficients, I've got a 6, negative 6, negative 84, positive 144, and we got to be careful here. There's a missing constant term, so that gives us a 0 for that placeholder. And now my k value that I'm plugging in with synthetic division is going to be negative 4, because negative 4 plus 4 would zero out this binomial. So I write my line here and bring down my first coefficient of 6. Negative 4 times 6 gives me negative 24, plus negative 6 gives me negative 30. times negative 4 is going to be 120, plus negative 84 is going to be, I think, what is it, 36? And then negative 4 times 36 is actually negative 144, plus 144 gives me 0, times negative 4 is still 0, plus 0 is still 0. So because we have a remainder of 0, that proves that yes, x plus 4 is a factor of h of x. For this problem, we're trying to see if x plus 7 is a factor of g of x. So let's do some synthetic division and see if we get a remainder of 0. So I've got my coefficients of 3, negative 28, positive 29, and 140. No placeholder zeros needed this time. And then, since we have x plus 7, negative 7 is going to be the k-value that I'm plugging in with synthetic division. So there's my line dividing my second and third rows. Bringing down the first coefficient, we've got the 3 down here. Negative 7 times 3 gives me a negative 21. Plus negative 28 is going to give me negative 49. Times negative 7 is, well, let's see, it's a positive. 7 times 40 is 280. 7 times 9 is 63. 280 plus 63 is 343. There we go. Plus 29 is going to give me 372. And I don't even know. I'm going to go to Desmos and calculate this one. So we've got negative 7 times 372. Definitely a calculator problem here. That is negative 2,604. Sure. And I mean, while I've got the calculator loaded up, let me add that to 140 just to get my remainder. So let's see here. Go down here. Answer plus 140 is negative 2464. In any case, that's our remainder. That's definitely not 0. So no, x plus 7 is not a factor of g of x. On this problem, to figure out if x minus 6 is a factor of g of x, we need to do a little synthetic division and plug in, it's going to be a k-value of 6 on this one because we have x minus 6. Alternatively, you could do g of 6 and see if it comes out to 0, but pick an approach and go with it. I'll do synthetic division because I don't really like dealing with huge exponents here. So we've got coefficients of 8, negative 58, 60, and we do have to be a little careful here because we're missing an x squared, so we need a placeholder 0, and we're also missing an x to the first, so that's 2 placeholder zeros, followed by the 140 over there. Let's see here. We had a k-value of 6, we said. We've got our line here dividing second and third row. Bring down our first coefficient, that's 8. 6 times 8 is 48. Negative 58 plus 48 is negative 10. 6 times negative 10 is negative 60. Plus positive 60 is 0. 6 times that is 0. 0 plus 0 is 0. 0 times 6 is 0. 0 plus 0 is 0. 0 times 6 is 0. And we come up with a 140 plus 0, which is 140. Since our remainder of 140 is not 0, that shows that no, x minus 6 is not a factor. For the next 3 problems, we need to show that the binomial here, x minus 5 for this particular problem, is a factor of the polynomial, t of x in this case, and then they want us to factor the polynomial completely using that. So they said show that the binomial is a factor, so we're guaranteed that x minus 5 is a factor. We just need to prove it. One way to do that is to use synthetic division on t of x and see if we get a remainder of 0. So we have our coefficients of invisible 1, negative 5, negative 9, and 45. And the k-value that we're plugging in this case would be positive 5 because we have 5 minus 5 would zero out that binomial. So 5 there. Let me do my line, and then let's bring down our first coefficient of 1. 5 times 1 is 5, plus negative 5 is 0, times 5 is still 0, plus negative 9 is negative 9. 5 times negative 9 is negative 45, and that adds up with 45 to give me a remainder of 0. Since we have 0 for the remainder, this last number here, that proves that yes, this is a factor that shows that x minus 5 is a factor. Now what this means is I can write x minus 5 literally as a factor of t of x. And next to it, when I factor this up and break this up, I can put the quotient of this t of x here. So this 1 represents a 1 x to the second power. It's one exponent lower than we started with. This 0 represents a 0x that we don't need to write. And then -9 is playing itself in this motion picture. So the question is, can we factor this x squared minus 9 a little bit further? And this is a difference of perfect squares, so we definitely can. So we've got the x minus 5 that we initially got from synthetic division. We also have, now if we take some square roots, the square root of x squared is x, square root of 9 is 3, so we have x plus 3 and x minus 3. For this problem, they want us to show that x plus 7 is a factor of r of x, and then factor r of x. So let's use synthetic division to start this process. I have my first coefficient of 1 for the 1x cubed. Then I'm missing an x squared, so we're already getting a little trickery going on here. We need a 0 to hold that place for the missing x squared. Then we have -37 for the x and 84. Since I have x plus 7 as my factor, that means -7 is my k value that I'm plugging in. So there's my line. Bring down my first coefficient of 1. -7 times 1 is -7, plus 0 is still -7. -7 times -7 is 49. -37 plus 49 is 12. And then -7 times 12 is -84, which adds with 84 to give us 0. Since we've got a remainder of 0, that means that we've just shown x plus 7 is a factor. So let's actually use it as a factor, so x plus 7. And then next to that, we can write our quotient of our r of x after doing this division. This 1 represents 1x to the one exponent lower, so 1x squared. This is minus 7x, and then we have a plus 12. I can break this down a little bit further, so I'm going to rewrite my x plus 7 so I don't lose it. And now I'm looking for numbers that multiply to 12 and add up to -7. Let's see, we got 1 and 12, 2 and 6, 3 and 4 works, -3, -4. So we can do x minus 3 and x minus 4, and this is fully factored. So for this problem, like the others that we saw recently, they want us to show that x minus 6 is a factor of the polynomial, f of x in this case, and then factor the polynomial completely. Now, it just so happens with these 4 terms here, if you were to try factoring by grouping and just follow it through to the end, you actually would factor this completely. That would be one way of doing this, just factor by grouping. But they want us to show that x minus 6 is a factor, so this kind of forces us to take the synthetic division route, at least for that part of the problem. And I mean, once we've started down that road, we might as well just continue down it. So, using synthetic division, we've got a 1 for the x to the 4th, that's our first coefficient. Then we have a -6 for the x cubed. Now we are missing an x squared, so we need a 0 placeholder for that, followed by a -8 and a 48. For my k value that I'm plugging in over here, since we have x minus 6 as a factor, that means positive 6 is going to be my k value, because 6 minus 6 zeroes that out. We've got our synthetic division line, and we're bringing down our first coefficient of 1. 6 times 1 is 6, plus -6 is 0, times 6 is still 0, plus 0 is still 0, lots of zeros here. 6 times that is still 0, but now we get something different. -8 plus 0 is -8. 6 times -8 is -48, and then 48 plus -48 gives us the 0 that we expected, because they told us this was a factor. We just needed to prove it. So remainder 0 proves that x minus 6 is a factor. So if we're going this route for factoring this thing, we can write x minus 6 as a factor. And then my quotient here, this is going to be 1x to the 3rd power, one exponent lower than we started. We have a 0x squared we don't need to write. We have a 0x we don't need to write. And we have a -8. We do need to check to see if we can break x cubed minus 8 down a little further. Since this is 2 perfect cubes, it turns out that we can. We can use the a cubed minus b cubed shortcut that splits things up into a minus b, a squared plus ab, and a positive b squared. So we've got the x minus 6, let's not forget that. But now splitting this up, this cubic part up, The cube root of x cubed is going to be x, so that's my a value in that first parentheses. The cube root of 8 is 2, so that's going to be my minus 2 that I'm putting in that one. And then a squared is x squared. Plus 2ab is going to be plus 2x. And then b squared is going to be a plus 2 squared, so plus 4. And this is now fully factored.